Okay, now in this same situation, let's actually assume, walking from thorn to searles, let's assume that we have some more data. So let's go down here and suppose now that we actually measure the data every minute instead of every second. I mean, instead of just at the beginning and at the end. So how can we, that certainly helps our estimate now. We know what's going on at least every minute. Like in this, now we have this where it starts out at 60 and still into 420, but you're sort of speeding up every minute, getting a little faster, which I've certainly had when I'm heading back to searles after lunch and realizing I have to teach soon. I start speeding up and speeding up and speeding up. So it's happened to me before. It's pretty plausible. Still doesn't mean you couldn't stop for 20 seconds, from the 2 minutes and 30-second mark to the 2 minutes and 50-second mark to come to a complete stop because you ran into somebody. It's not the full picture necessarily, but let's think about how we can estimate the data again, and let's draw the sort of graph, the velocity versus time graph. So again, the horizontal axis is time, and I really probably should say in minutes, time in minutes. The vertical graph is velocity in feet per minute. Right, and then now we have more data points we can plot, right? So we've got these timestamps. This isn't a perfect plot. I should be doing this on a grid probably, but so we've got height 60 here, height 200. Let's say height 200 is about there, 270, 330, 380, and 420. I'm trying to get this approximately. It's not exactly linear or anything, but it kind of goes up like that. This dot's probably a little farther over. You can draw this better in your notes, I'm sure. All right, so now we have these data points, right? And the question is, how can I now estimate the velocity? Well, I mean, the total distance traveled, knowing these data points. Well, again, there's some choices to make because it's kind of this interesting thing here, right? Before we had one time interval, but we had two data points, right? We just had the interval from 0 to 5, but we had these two possible values. And so we used one of the values, sort of the beginning value, or the value at the left-hand side of the interval, if you want, first, or to do one calculation, and then we used the value at the right-hand side of the interval to do another calculation. And so we're throwing away some information. There's something sort of similar here. There's like, I could, if I want to assume, one way to estimate would be to assume, let's just take the value given at the beginning of every minute and just assume that's the speed. Let's assume we're going 60 feet for the whole first minute, 60 feet per minute for the whole first minute. Let's assume we're going 200 feet per minute for the whole, from minute 1 to minute 2, from time t equals 1 to t equals 2. And so on, right? But then notice we wouldn't actually be using this value 420 because it kind of, we're throwing that away at the end. So one of our guesstimates could be use the speed at the beginning of each time interval. And I'm going to say, just because it's going to come up later, the left, if you think about this picture over on the left, over here, this picture of this graph, getting left of each time interval. Right, so if we did that, we'd assume we'd be going 60 feet per minute for the whole first minute. So we'd have like, so first minute, we'd have 60 feet per minute times 1 minute. And then from t, that's maybe I really should say t equals 0 to t equals 1. Right, and then t equals 1 to t equals 2 would be 200 feet per minute times 1 minute, and etc. Right, so 2 to 3 we'd have 270 times 1, start to being a little lazy here, from 3 to 4, 380 times 1 minute, from 4 to 5, 420 times 1 minute. And we basically add all these up because you're assuming now you're going this speed the first minute, this speed the second minute. I mean, this distance, this is 60 feet. This is 200 feet. This is 270 feet. This is 380 feet. And this is 420 feet, right? And you would get an estimate from that. You would sort of just add all these up. And oh, I should have done that in advance, shouldn't I? Let's see, that's a, oh my God, that's a 3, carry a 2, 1,130 feet. I could totally be wrong about that, but I think I got 1,130 feet from that. Okay. By the way, I want to think about what this looks like as a picture, because as a picture, there's a way to represent distance, right? Because if you think back on this picture on the left over here, this velocity graph, assuming it goes 60 feet per minute for the first minute, this is height 60 right there, that little yellow thing I'm drawing. Let me zoom in. That's 60, and then times a minute. This is actually like, yeah, this is a rectangle with height 60 feet per minute times base 1 minute. And so this area right here is 60. And a similar way, this is height 200. And so this really is feet because you're multiplying feet per minute times minute, feet per minute times minutes. Areas in this graph, because the vertical axis is feet per minute, the horizontal axis is minutes, areas where you multiply of horizontal distance times vertical distance will be, the minutes will cancel, you'll get feet. And so it's kind of amazing. So we actually get something like the following visual representation of the distance traveled, right? So it's like this. And notice that that last time, that last speed right here does not come into play because we're not really using it. I sort of lost my data points a little bit. Let me just color them back in again. So these are my data points. And I'm sort of only using the times, the timestamps in these, but not this one, right? Okay, so 280, let's see, that was 280, that was 3, oh, I can't, 6,200, 270. I messed it up, didn't I? Oh my God, I don't want to re-record this, so you guys are gonna have to bear with me. But you can see what I messed up. I skipped over 330, right? Oh my God, I did it here too. Hopefully you guys caught me, saw that I was messing up. Oh, that's not 420. Oh my God. Okay, that's 380. Somehow I just skipped the 330. So that was my bad. Oh, I thought this number looked wonky because I have done it before. So that's not right. You should pause. What you should really be doing in these videos is pausing, checking my work, making your own computations. Don't just taking it from me. In fact, maybe I'll pause for a second. Okay, I paused the recording myself and checked the numbers. And yeah, this works out to 1,240 feet, I think. So if you add up all these, and again, we can think of it as the area of these, the combined area of all of these rectangles right here represents the distance, right? So, or the approximation. Distance is the area of the total area of all the rectangles. Okay, so that is using the speed at the beginning or the left-hand side of each time interval. Again, on this, notice each of these we're using the left. We have a time interval like this, and we're using the left side of the interval to make the height. And so you can, one way you can see this is at the top left of each of these rectangles is the height we're using. Okay, so we could do the same thing as another estimate. We could do the same thing, but we could use the speed at the end of each time interval. So we could assume that in the first minute, we're actually from times 0 to 1, we're actually going 200 feet per minute. And from time 1 to 2, we're going 270 feet, and then so on, all of these numbers, and not using that number, right? Okay, so if you do that, let's try that. So we could use the speed at the end. End of each time interval. And actually the end of the time interval is sort of the right-hand side if we're depicting the intervals graphically. And so if you think about that, well, okay, our first number, let me use a different color here. Our first number we would be using is 200, 200 instead of 60 in this first minute, right? So we would get from t equals 0 to t equals 1, we'd have 200 feet per minute times 1 minute, which would be a total of 200 feet. And then we would play the same game, right? So from 1 to 2, up here, we look at this number, 270. And so that's 270 times 1 minute. That's 270 feet. And you can sort of see what happens, right? We're actually just going to get, because we're using the time interval 1, these numbers don't change. So maybe if I'm being a little a little more foolhardy about this, I'll just say, look, we're just going to add these 5 numbers up, right? So we get 330, 380, 380, and 420. And I add all these up. So this is sort of et cetera over here. I add all these up and I get 1,600 feet. Okay. Also, so there's okay, so that's another estimate. 1,600 feet's an estimate. 1,240 feet's an estimate. Probably the larger one's an overestimate and the lower one's an underestimate because of, we can see sort of some pattern to the data now. It's kind of, the speed's kind of increasing. I do want to notice that I can draw a similar picture as this one, as this picture right here, right? And I was going to draw it on the same picture, but I probably should be, let me see how clever I can be. Maybe I can copy. Okay, let me move this down here. And let me try to erase all the yellow. Kind of what I want to erase, right? And we can sort of, again, represent this pictorially now, but notice in the first minute, instead of using 60 as our height, we're using 200 as our velocity number. And we're multiplying it by this 1 minute. So that, you know, this is 200 feet per minute times 1 minute. So that gives us 200 feet. And then in the second set from time t equals 1 to t equals 2, we're using the 270 number, the 330 number, and the next minute, the 380 number. And these don't look like rectangles, but you get the idea. And the 420 number. So keep messing up the data here. 270 there, 330 there, 380 there, 420 there. And that's another estimate. And now this is called, this one over here, this one back up here is called a left sum. Because we're summing these rectangles. And like I said, the top left of each rectangle is sort of the data point we're using. We're using the beginning of each time interval to make this, which is sort of, so that's the left, they call it the left sum. Whereas over here, this is called a right sum. Because we're using the end of each time interval, which puts these points on the top. Again, I could probably make these these points a little more prominent again, now that I drew over them. These points are on the top right of each. Okay, so that's a way to get, oops, and notice we don't use this point, this 60 value in this interval. So we're throwing one value away. Again, we could average the two. So maybe a third approach would be to average them. Average the left plus the right estimates. And so that would be 1240 plus 1600 over 2. Ooh, 2840, 1420, I think. So that could be a third estimate we could come up with if we like. All right. I think you're getting the idea here. Next, we'll talk a little bit about what happens when you take more and more time intervals, like more and more frequently, more and more readings, shorter and shorter time intervals. And we'll talk about that next.